Thank you all for making it right after lunch. I want to start with just a quick show of hands. So, who considers themselves comfortable writing Android tests? And who has Android tests alongside your production apps? And then, who is satisfied with the number of tests they have for their apps? Many less hands. Testing your code can take more time up front, but there's many benefits that come later on. For one, you can change or refactor your code with confidence. Often, when changing or refactoring your code, things can break. And you try your best to catch them, but there's often something that you forget to click through. By automating these tests, you can be more confident that your changes didn't break anything. And then not to mention the time that you'll save from not needing to do as much manual testing. Tests can also be a form of living documentation. In order to understand how part of the code is expected to behave, you can pop open the tests, and if they're well written, there'll be a good description of the expected behavior. And then with that, you can save time trying to understand the code and spend more time thinking about what code you're trying to write, the problem you're trying to solve and implement. And then writing tests also encourage having maintainable code. If you're actively writing tests, you want your code to be architected in a way that's easy to test. And both writing maintainable code and writing for tests often follow the same patterns of single responsibility that gives you cleaner, easier to maintain code. But writing tests for Android can be hard to learn, and many of us feel lost when it comes to test type. There are so many libraries whose APIs you need to learn and make sure work well together. You can get unclear errors and not know where to go. The issue might even be that your libraries don't play well together, taking your focus away from what you're really trying to do, which is write those tests. And with so many factors, it's hard to get comfortable writing tests and making testing a habit. This overhead is part of why it can be so hard to get tests written for your app. Half of the people who responded to this poll don't have any Android tests with their app. And when you're feeling lost and not seeing the benefit of the time that you're putting in, it can be hard to keep motivated to keep up with testing. Sure, there's sometimes time constraints from clients, and that's why you're not getting them in. But so much of the struggle is from how hard it can be to write some of these tests and how long they can take to build and run. To run an Android test, you have to build the entire APK, install it on a device, and then also have the test instrumentation runner, and then wait for the test to run. So many of us wish we had better testing in place. So what's holding us back? From the ever-accurate source that is Twitter, I overwhelmingly heard that 1, they're hard to write, and 2, that they're slow to run. These are both very valid points. Test-driven development is a recommended process where you write a failing test before you write the code to make them pass. It's an iterative process where you write the test for the feature you're about to add or the behavior you're about to change, and then write the bare minimum amount of code to make it compile. So then you run it and make sure it fails, so it's red. Then you write the bare minimum amount of code to make it pass, to make it green. And then you stay at this step until you have your passing test. At that point, you can either refactor the code that you wrote or move on to the next part of the feature, writing another failing test, writing the code to make it pass, refactoring if needed, and going on. With this process, you need to run your tests frequently. With how long Android tests often take to build and run, it's detrimental to the recommended iterative TDD process. And when it's hard enough to solve the problem of creating tests yourself, it can be even harder to get an entire team on board with these challenges. And when your entire team isn't on board, it's hard to keep a test suite up to date. You'll always be playing catch up if you're trying to write tests for your own code and for others' codes, and you might end up just giving up. One of the best ways to solve this is to try to work on removing some of the hurdles that come with testing so that others have an easier time coming on board. There's a 70-20-10 split guideline that creates a pyramid where 70% of your tests are unit tests, 20 are integration tests, and 10 are UI or end-to-end tests. And this means that 30% of your tests, if you're following this pattern, are likely to interact with the Android framework. Because no matter how much we try to architect away from it, there will always be some part of our code that interacts with the Android framework. These Android tests can be some of the hardest to write and take the longest to run, but it's still code we should test. Writing small, fast unit tests can sometimes be the easiest and quickest way of automating the verification of the code that we write. But as we build a feature or a screen, we need to verify how the small pieces fit together with each other and with the Android system. These are the kind of tests that this talk will focus on. I'll focus more on integration and UI tests than unit tests. I'm also going to talk more about testing tools than on what to test. And today I'm going to talk about one category of options in particular, and that is AndroidX Test. Before we dive in, a couple words on who I am up here speaking to you. I am an Android engineer at Buffer. Our apps make it easy to schedule posts for social media, track performance, manage accounts. We are a fully remote company, so feel free to ask me more about them or working remotely. I'm also an author and editor at RayWonderlic.com. I'm on the Android and Kotlin team helping to make learning materials on those topics. Then I'm also a native here in Chicago, so you can come ask me for recommendations if you're out of town, or co-work sometime if you're from town. And then I'm also a happy hedgehog and cat owner, and working for a social media company. They do have their own Instagrams. And thanks again for making it here for the second half of day 2. My slides and the resources are posted to Twitter. If you want to follow along or catch them later, I'll also put them in the Chicago Roboto Slack. So there are so many testing tools at our disposal to try to make testing easier. There's JUnit and Retrofit Mock and Espresso and Makito and Robolectric and Spec and Kotlin Test and Mach8 and Kakao and so many others. So how many of you use at least one of these tools? All right. These tools live to make testing easier, but it means you need to remember all these tools, pick between them, remember how they work together, what their APIs look like, which ones can run on the JVM, which ones need to be run on a physical device, and so on. Google is trying to help solve this with AndroidX Test, which they announced at the last Google I/O. It's a set of testing tools that are part of Jetpack. It includes some of the libraries you might already know, for example, Espresso. With it, the goal is that there should be less thinking about which library should I use and how do I use it, and more test writing. Also, there should be less thinking about where to run your tests. When using AndroidX Test, you can run them anywhere. Device, computer, CI, you name it. Even UI tests, you don't have to rely on a device or emulator without really needing to do anything else extra. Some other things that might matter to you is it's open source, so feel free to go look at that source. And then Google is also updating their documentation to use AndroidX Test, so according to them, it's going to be is the standard for testing on Android. So what is included in AndroidX Test? What are we looking at today? Google describes AndroidX Test to have 4 distinct sections for different testing needs, and we'll cover each one in this talk. The first is the JUnit 4 support, and it has the runners and the rules you might already know if you're familiar with testing on Android. It also allows you to get the application context in your tests in possibly an easier way. You can almost think of this section as scaffolding to build your tests on. Then there's core, and this one has a bunch of new stuff. Much of it has to do with handling activities and fragments. This is what you use to set up the situation or scenario that you're testing, often called the given section, such as given valid credentials. This has some of the most exciting bits in my opinion, and we'll look at them in detail a little bit later. It also has some great builders for Android objects that might be hard to create to use for your tests otherwise. There's also Espresso for your when case, for example, when this button is pressed. And it has everything that you need for your UI testing. This is the same Espresso you might already know if you are familiar with testing on Android, just brought under the AndroidX Test namespace. And then finally, there's Truth, which has some more new stuff. It has some nice matchers for Android objects, making your tests easier to read and to write, as well as providing some more readable error messages. We will learn about some of these features by walking through writing a couple tests. And these tests will be for an app called Task List that's used to break down tasks that need to be done. Sometimes tasks can be overwhelming until you break them down into smaller parts, for example, learning how to test on Android. We'll look at each of our 4 sections I just described: JUnit, Core, Espresso, and Truth. So with that, let's get started. First step is JUnit. Remember that the JUnit section is the JUnit 4 support with the runner and rules you might already know if you're familiar with testing on Android. It also allows you to get the application context in your tests. And you can think of this step as scaffolding. There are 2 dependencies that we need to add in order to get started. The first is just plain JUnit 4. This one isn't a part of AndroidX Test, but it's what it's meant to work with. And then there's the AndroidX Test library that we use with JUnit. Notice here, or here rather, that I'm using test implementation instead of Android test implementation to include these dependencies. I'm doing this to show you that you can run these tests off device, off emulator. If you want to run them on device, you do need to use Android test implementation. And then also, you need to make sure to specify the test instrumentation runner in the default config block of your Gradle file. These, as well as some of the other dependencies I'll show, are usually automatically included for you when you generate a new Android project in Android Studio. But in case you're working with an existing project that doesn't have them, or for some other reason, I'm sharing them anyway. So here we go, setting up the test class for the main activity. This tells JUnit to run the tests inside of Android JUnit 4 test runner instead of the runner built into JUnit. Android JUnit 4 is a test runner that runs JUnit style tests for Android tests. When used in Espresso test, it helps control the launching of the app and running UI tests. The run with annotation is a part of the standard JUnit that Android JUnit 4 is passed to. Then Android JUnit 4 is from the JUnit part of AndroidX Test. You can use this runner instead of Robolectric test runner when running Android tests locally on your machine. With this section, there's also a different way to get the Android context. Previously, you could get both the app under test context and the instrumentation context from the instrumentation registry. And it wasn't necessarily clear from the naming which was which and which you might want. There's both get context and get target context. By using the new application provider get application context, it's clear that it's the app context that you're getting. And this is generally the one that you want. It's easier to think about this way, not needing to remember if get context or get target context might be the one that you want. And then with what you have scaffolded already, you're already set up for tests to run on a device, but you have one more step to run them off device on your machine. And that's to include the Robolectric dependency. It's starting with Robolectric 4.0 that you can run all of these tests both on and off device, so make sure you're using version 4.0 or higher. And then one last thing is to make sure your test options are set up to include Android resources in your unit tests. And with that, we'll move on to the second part of AndroidX Test, which is core. This one has a bunch of new stuff. Just as a reminder, it has a lot with handling activities and fragments. This is where you can set up the situation or scenario you're testing, often called the given section. And this section is exciting, I think. I like the stuff that comes with it. It also has some builders for Android objects, which we'll look at too. We don't need to add any more dependencies. At this point, we're covered with what we already added. So let's get started writing the first test. So this is a basic launch test, just to test that the main activity launches without crashing. I don't normally find value in a test like this if I have other Espresso tests along with it. But it's good and simple to get started learning, and it can be a valuable addition if it's the only test that you can add for that screen. It will catch if there's a crash when the screen is open, which you definitely want to catch before your users do. We have a function with the test annotation, and that's a part of JUnit. And then the more fun stuff is inside. This uses the new activity scenario, and it's used to launch the main activity. You call activity scenario.launch with the activity class name to do this. So this is cool. You can use this instead of the activity test rule you might already know. You have the option to pass in your own intent if you do want to add some extras. What this does is it creates the activity and brings it to the resume state, where it's visible to the user and ready for input. Because this can be used on or off device when you're running it, you don't need to remember activity test rule versus Robolectric setup activity or Robolectric build activity for on or off device tests. You can just use this one scenario for all of those cases. And then activity scenario handles much more than just the launching of your activity, but also handles all of the synchronization with the system and provides support for lots of things, such as scenarios around your activity's lifecycle. To get started playing with this, when you launch the activity, you can keep a reference to that scenario. You could then test the way your app behaves under certain lifecycle events by using a move to state call. You can, that way, step through lifecycle events, verifying your app's behavior. The framework will keep you from stepping through in an invalid way, eliminating the cognitive load there. For example, it won't let you move on after you've destroyed the activity. If you do want to test how your activity behaves after the system has destroyed and recreated your activity, you can use the recreate method. With it, the current activity will be destroyed after the data is saved with onSave instance state, and then it creates a new activity with that saved state. After this method call, the activity state goes back to the same state as the previous state by using the onSave instance state. It sounds to me like this can be a way to test how your app behaves with configuration changes, but I have not verified that. And then one last thing here is you can use close to free all the resources and bring the test to their initial state. It's recommended that you do this if you're not using the scenario rule to avoid flaky tests, which will take care of this for you, which, speaking of, there's an activity scenario rule. And you can use this instead of using activity scenario to launch your activity manually in each test. And you can use this instead of the activity test rule you might know. In case you don't know what a test rule is a tool to change the way tests run, sometimes adding additional checks or running code before and after your tests. In this case, it handles the launching of your activity before your test and closing everything, freeing the resources, and bringing your test back to their initial state after the tests. So these are the same things that happen if you were to manually do activity scenario.launch at the beginning and then scenario.close at the end. And then you can access the scenario directly from the rule and use it for all the same things just by using the scenario property on the rule. The next part of the new core stuff has its own dependency to add. As you can tell from the name, fragment testing, this one deals with fragments. It's a fragment scenario, similar to the activity scenario, but for testing fragments in isolation. No more do you need to build a solution yourself or set up the entire surrounding activity. The bundle args you pass in are optional, so you can have args or not. It has the same control over lifecycle events that you get with activity scenario. When using this, you do need to make sure you build your fragment in a way to be relatively independent of the activity that it's in, but you should probably want to do this anyway, so that you can use your fragment in different places. You can also access the fragment block with onFragment. There's also a similar onActivity method for the activity scenario. Eric had a great example yesterday of how this can work alongside with navigation component. Here, a bundle is created for the args. Then it started with launch fragment with container to launch the fragment. Then the mock nav controller is set in that onFragment block. And then after that, you can control the view using Espresso, and we'll cover Espresso in just a minute here. Then one more part of core includes builders for some Android objects that might be hard to create otherwise, whether they have private constructors or for some other reason. This includes builders for application info, package info, motion event pointer coordinates, and motion event pointer properties. They all follow the pattern of the name of the class with the postfix builder. So here we have package info builder and application info builder. Then you can chain together using the builder pattern to set some properties and then build it. So typical builder pattern. Now the third part of AndroidX Test is Espresso. It's for your when case, for example, when this button's pressed. And it has pretty much all that you need for testing your UI. This is the same espresso you might already know if you're familiar with Android testing, just brought under the AndroidX Test namespace. It handles some multi-threading and synchronization for you and tries to have a readable API for interacting and testing your UI. It has all your matchers and assertions for testing your view, again, now either on device or off device. To get started with the main parts of Espresso, you need to include the Espresso core dependency. Again, here I'm using test instrumentation instead of Android test instrumentation, so I can run these tests locally. If you're not familiar with Espresso, there are three main things to understand: view matchers, view actions, and view assertions. View matchers search to match a view that is on the screen so that later you can perform actions or make assertions on them. The first one we'll use is by ID, which can be the most common, but you can also search by text, content description, so many other things, and you can even write your own. And then view actions are used to perform actions on views that were matched, such as a click. For example, once you use a view matcher to find a view with the ID floating action button, you can perform a click on it. Again, there's lots of actions and gestures that are provided, and you can write your own. This step is sometimes optional to use, as not all tests will need you to perform an action. Then finally, view assertions. These verify something is true about a view that you've matched. You can check if a view is visible or contains the text that you expect. Again, there's many different ones of these, and you can, again, write your own. So here, the main activities launch using the activity scenario, and we test that an add button should be on the screen. With ID is a view matcher to find the button with the ID button add list. Then matches is our main view assertion. Is displayed is a view matcher that we pass into it. This checks that the view with the ID button add list is also visible on screen. Previously, you might have had to learn one API for Espresso and to run your UI tests on device, and potentially a separate one if you want to run them off device on your machine. And you can use the single Espresso API for both. Espresso has some other libraries to help you do some other things, such as testing with web views and accessibility checks. Two that we'll look at quick here is for intents and recycler views, and the recycler views is part of the contrib library. This is a test that when a list item is selected, the detail view is shown. There's a lot here, so I'll break it down. We start the activity using the activity scenario like before to launch the activity. Then, the first library we added for intents is used. We initialize intents to listen for intents that are launched. Now to use the recycler view matchers and actions that are a part of Espresso contrib. We use the recycler view matchers to click on the first task in the list. So this is a view action. We do this first by matching the recycler view by ID, and then use perform action on item at position 0 to click on the first item in the list. Note that the detail activity won't actually open at this point. When using the intent matchers like this, it intercepts the intent so that we know that it was sent, but it's not actually opened. This is helpful if you want to test that it was initiated, but you don't want to do all of the setup that might be required to actually open in a test, such as maybe stubbing the network layer. And then back to that intents library, we verify that the intent was sent using with the component detail activity. So this is our verify step. And then finally, you always need to release the intent matcher. I like using a custom DSL for this, otherwise I won't inevitably forget. This starts to show you how you can use different parts of AndroidX Test together to seamlessly build more complex tests to run both on device or locally. Now finally, fourth and last, truth. This is an optional assertions library, but it can make your test more readable and error messages easier to understand. So while it's not required in the way Espresso can be for some tests, it can be a nice to have. And it's all about the verify step, sometimes called the then step of your test, the part that asserts that your app behaves as expected. AndroidX Truth is built on top of the Truth library from Guava. Guava's truth can be an alternative to JUnit or ham-crest-based assertions. In general, you use truth to verify that an object has a specific property, using phrases that read almost like a sentence. For example, using the intent subject from the AndroidX Test Edition, you might code using the sentence, assert that intent has no action. This is an example of how the AndroidX Test extension of this library provides some cool matchers, but let's use some more by rewriting the previous test to use truth for the assertion step. To get started, we need to add the dependency, as you might expect. It does follow a similar naming convention to all the other AndroidX Test dependencies. And then this is the same test as before, with just the assertion step changed. So let's take a look at that. You grab the first intents using getIntents, which returns a list of captured intents. This is apart from the Espresso intents that we looked at before. Then you use the intent subject assert that. This returns an instance of a truth intent subject to test for that intent. Then you have an assertion on it. Here we're verifying with hasComponent class to make sure it's our detail activity. Reading it out, it says, assert that intent hasComponent class detail activity. Other intent insertions include extras, actions, flags, type. There are subjects for so many different things, so let's look at a few more. The detail activity in this app provides its own start intent by using new intent. Here we test that it has the bundle extras that we expect, but we'll break this down to make it easier to look at. For reference, here is the new intent method. It takes a task list and a context, builds an intent for the detail activity, and adds the list ID as an extra. This calls the method on the detail activity to get the intent we want to perform our tests on. We'll be testing that this method builds the intent correctly. Notice that we're using the application provider I mentioned before to get the application context to pass in a parameter. So application provider, get application context. By using assert that intent.extras, we're able to get a bundle subject to perform verifications on. Here we're looking that it contains the key extra task list. Sure, this could be chained together instead of assigning this to a variable, but I have it written this way so that you can see the type explicitly. To keep building on that, we can use the key to get for that integer extra to get an integer subject. We can then use it to verify that the value is equal to the task list ID as we expect. I mentioned how nice the error messages are, so let's take a look at a couple. This is one for if the component class is incorrectly main activity instead of detail activity. It clearly states the value that's being tested, the intent class name, what was expected, detail activity, and what the actual result was, main activity. Compare this with the error that you get when the test is not using truth. I'm not going to walk through all that, but know that it basically means the same thing as the previous slide. Here's another for the verification that there should be an extra task list, but there's a task name one instead. So we see that we're testing the value of intent get extras. We expect it to contain the key extra task list, but instead it has a bundle with the extra task name laundry, not what we wanted. And then one more. Even checking for integers can be more understandable. So here we see that we're testing for the value of intent get extras get int extra task list. We expected it to be 4, but it was 5. Compare this to the error message that you get when using the JUnit assert equals for integers. Sure, you still have the same expected and actual, but the error message doesn't include the information we had before that's about. We're looking at the intent get extras get int extra task list. So it takes a couple more steps to go look at why the test failed. There are lots of different subjects with assertions and messages like these. Just here we looked at intent subject, bundle subject, and integer subject. There are also subjects for all these Android classes as well that are on top of the subjects included in Guava's truth. All this is to say is that Google wrapped up their testing libraries under the AndroidX Test namespace, while also giving us some new things. These libraries are in 4 categories. JUnit, which has your needs for scaffolding and accessing the application context. Core for setting up your tests, launching activities and fragments, and building Android classes. Espresso for all your UI-related testing needs. And Truth for making your assertions just a bit nicer. The testing APIs you're familiar with from before are all still available right now, but they may be under a different namespace or no longer be the recommended strategy. The tests that we wrote in this talk, and any test using these libraries, can be run on or off device. All you need to do is drag the test into the appropriate test or Android test directory and make sure you have the correct test implementation or Android test implementation for your dependencies if you don't have them set up for both. And now you can hopefully use the same APIs across layers of testing and worry less about what the API is or where you'll run it, and more on the test writing itself. Now, before we go, I do have to make a mention of Project Nitrogen. I don't know that much about it yet, but I'm excited to learn more. It's a test executor meant to be a single entry point for all tests in any execution environment, from local to on-device to CI. With it, you should be able to even more easily move tests between different runtime environments, such as on-device or locally with Robolectric. It also is supposed to give you a lot of data from your tests, like logcat, screenshots, and battery performance, from what I've seen. I believe it was announced at this previous Google I/O, and I'm hoping that we learn a lot more about it at this upcoming I/O. With that, I want to thank you all again. Up on the slides is a link to the resources, which includes these slides. I also have them posted to my Twitter, and I'll put them in the Chicago Robotos slides channel in Slack. You can come find me after for any questions about this talk, testing, remote work, or just want to come say hi and grab some stickers. I did bring stickers. It's been great sharing with all of you, and thanks again.